Okay, now we're going to talk a little bit about how the number of neutrons is going to affect the atomic mass. So what we're going to do is we're going to look at the relative abundance of different isotopes, and we're going to use those abundances to calculate the atomic mass. So if we're looking at carbon-12, carbon-13, we will notice that in the universe, or at least on Earth, carbon-12 has about 98.93%. Carbon-13 has 1.07%. Now, when I do this problem, I want to figure out what the average atomic mass of all carbon. So all carbon on Earth. So I have to take into consideration this percentage and this mass, and this percentage and this mass. So here's our calculation. We're going to take the percent of A times the mass of A plus the percent of B times the mass of B. So let's just go ahead and call carbon-12, put a 6 here, that represents the A. Carbon-13, I'm also going to put a 6 here because they both have 6 protons. Now, the mass of A and the percent of A. The percent is right here. And since it's in an actual percentage, we can't enter that in our calculators. So what we're going to do is I'm going to put the percent of A, sorry, color coordinating. I'm going to put the percent of A, which is 98.93 over 100, times the mass of A. I'm going to add that to the percent of B, which is 1.07, sorry, we got smaller, 1.07 over 100, times the mass of B, which is 13. Now we could keep going if we had more samples, but today we only have carbon-12 and carbon-13, so I'm only going to incorporate these two into my calculations. Now I get my calculator out, and I'm going to do the math, and I'm going to write down the answer right underneath my problem. And my calculator works. So I have 98.93 divided by 100 times 12 equals 11.8716. I'm going to write out all the numbers. We'll worry about significant figures later. Now I'm going to do this calculation. 1.07 divided by 100 times 13 equals 0.1391. I'm going to add these two numbers together, plus 11.8716, and the answer I get is 12.0107. Now when I look at this, if I asked you to do it in the correct number of significant figures, this one has 3 significant figures, this one has 4, these both have 2. However, for the purposes of this question, you will not be asked significant figures because you would only be left with 12. And that's not very accurate. So for this purposes, or for the purposes here, we'd probably take it up to 4 significant figures. The answer is 12.01. If you look at your reference table, they take it out to 5 significant figures, which means this 0 would be rounded up. So the answer for the atomic mass of carbon is 12.011.